This video is meant for Mrs. Rose's AB Calculus class, and it is on exponential functions, their derivatives, and their integrals. Okay, so the exponential function, the main things you need to know are the shape of the graph and the 2 points, 0, 1, and 1e. The domain are all numbers, ranges everything greater than 0. It has a horizontal asymptote at y equals 0. And we're going to see that the first derivative is always increasing, or always positive, and the second derivative is always going to be positive as well, because the graph is always concave up. Okay. When you're solving logarithmic functions, we are going to have to get rid of this base e. So if you take like this, then what we can do is take the exponent, x plus 1, and bring it down in front of the natural log, and then we all know what natural log of e is. It's just 1. So we just have natural log of 7 equals x plus 1. Subtract 1 from both sides, and when you plug it into your calculator, you get a decimal answer. The other ones are solved very similarly, and the notes are on Edline. The derivative of e to the x is my favorite derivative because it is so easy. The derivative of e to the x is e to the x. It's awesome. Okay. The first one we're going to do is the chain rule problem. So if you have e to the u, we also have to multiply by du dx. For example, if we have e to the 5x minus 2, we're going to make the exponent your u, and the derivative of that is 5. So the derivative of e to the 5x minus 2, you just rewrite what you were given, and then multiply by the derivative of the exponent. For our third one, we're going to look at the derivative of e to the negative 3 divided by w squared, and the entire exponent is your u. And then we're going to take the derivative of that, 6w to the negative third, and when you go to write the whole derivative, you just rewrite the first piece, e to the negative 3 divided by w squared, that stays the same, and then you multiply by the derivative of the exponent. So I'm going to write this as 6e to the negative 3 divided by w squared over w cubed. Our last example for the derivatives is going to be a product rule, where we're going to take the derivative of x squared first and then multiply that by our second function, plus x squared times the derivative of the second function, which is e to the negative x, times negative 1. So if I take this negative and put it out in front, so we have negative 2x e to the negative x minus x squared e to the negative x. And then what I can do is take out the greatest common factor. Okay, for questions such as this one, find the slope of the tangent line at a given point. You first need to get the derivative. So dy dx equals, you rewrite e to the 2x, and then you multiply by the derivative of your exponent, which is just 2. To get the slope value, we're just plugging in x equals 0 into the 2x here. And so we're going to get e to the 2e to the 0, which is just 2, because anything raised to the 0 power is 1. Okay. Our next example has to do with relative extrema and points of inflection. It's a fairly long example. The notes are on Edline, but remember that to find relative maximum or minimum, you have to find where the first derivative equals 0. Check to see when the first derivative is positive and negative. And then if it changes from positive to negative, you're going to get a relative max. If it goes the other way and changes from negative to positive, you're going to have a relative min. The second derivative, you're just looking for a sign change, which is on this graph going to happen at -1 and 1. So f of x has points of inflection at -1 and 1 because the second derivative changes sign at those x values. In case you're interested, this equation that we took the derivative of on the previous slide is a normal probability density function that they use in AP statistics. Okay, now we've gotten to the examples of integrals of e to the x. Again, these are my favorite because they're so easy. The antiderivative of e to the x is e to the x plus c, and the antiderivative of e to the u is e to the u plus c. So for our first example, we have e to the 4x minus 3 dx. The entire exponent is going to be u. And like always, du is going to be the derivative of that u. So for this function, we need to have a 4 and a 1/4. So when we go to rewrite this in terms of u, this is going to be 1/4 e to the u du. The antiderivative is just e to the u plus c, so we have 1/4 e to the u plus c, and then you plug your u back in. For our next example, we're going to look at 5x e to the negative x squared dx, and your entire exponent is your u. The du is the entire derivative of the u. But this one's more tricky because you have this 5, and you're going to need to pull that out and replace it with a -2. So we're going to have 5 over here, and then it needs to be over -2. This -2 and x and this dx are all going to be from your du. So what we're going to write is -5/2 integral of e to the u du, and then the antiderivative is very easy. -5/2 e to the u plus c. The final step is plugging in what u is. We can also do similar examples with definite integrals, like this one. So e to the u is going to be the -x, and du is going to be -1 dx. So I'm going to need a negative on the inside and outside. The other thing we need with u substitution definite integrals is u numbers. So if you plug in a 0 into -x, you're going to get 0. And when you plug in a 1, you're also going to get -1. So I'm going to have -0 to -1 e to the u du. Now this one's tricky because the numbers are now backwards, but it's easily fixable, particularly because we have this negative out in front. So if you flip your limits of integration to get -1 to 0, your negative sign that was out in front just goes away because you flipped the limits. And this is still e to the u du. Antiderivative is very easy. We have e to the u evaluated at those two numbers. You plug in 0 first, you plug in -1 second. So this is going to be 1 minus 1 over e, and that's it. I hope you learned something. There are a few other examples available on the notes on Edline. And if you have any questions, please see me during vocabulary morning or class.